We're going to pick up here with number 7 on our study guide. It says the box plot below shows the age of the Academy Award winner for Best Actress from 1985 to 2012. Part A, we want to give the 5-number summary for our data. So remember, the 5-number summary is the minimum, the first quartile, which is Q1, the median, the upper quartile, which is Q3, and your maximum value. So for that, I would say that my minimum value, that's where my whisper begins down here. It's right above 20, so I'm going to estimate 21. The next value is Q1, the lower quartile. That's where this box begins. It's just below 30, say about 29. My median is in the middle where the boxes meet. That's 34, just below that 35. The upper quartile, Q3, where this box ends, just above 40. I'm going to estimate that to be 42. And then my maximum, it's tempting to put where this whisker ends about 61, but you have this value here. It's an outlier by the star up here, but it still is part of the data set. And so that maximum value appears to be around 80. Now, what percent of the actresses were less than 42? The thing about box plots to remember is that no matter how wide or how narrow the component, each piece contains about 25% of your data set. So this longer whisker contains about 25% of your data, and so does the shorter whisker. This left-hand box, it's a little bit smaller than the right-hand box, but they both contain about 25% of your data. So less than 42. 42 is this mark right here at your third quartile, and so less than that, you've got this 25, this 25, and this 25. Those 3 25s gives you a total of 75%. Moving to part C, calculate and interpret the IQR. Remember that the IQR is calculated from Q3, your upper quartile, minus Q1, your lower quartile. So Q3, we just said was 42. And Q1, we said that was 29. And that's going to give me 13. And so to interpret this, the IQR from Q3 to Q1, that's the middle 50%. So I would say something to the effect of the middle 50% of Academy Award winners for Best Actress are within 13 years of one another. There's a 13-year gap in between those middle 50%. And then to calculate my fences for outliers, we had some formulas though for those. For your upper fence, we'd use the formula. It's Q3 plus 1.5 times the IQR. And so in this case, this would be Q3 at 42 plus 1.5 times 13. So on my calculator, I will say 42 plus 1.5 times 13. And that gives me 61.5. So that whisker is coming up to 61.5 right here, and that's why 80 is an outlier, because it's above that fence. There are no lower outliers, no stars down there, and we can see the reason why would be if we do calculate that lower fence, it is Q1 minus 1.5 times the IQR. And so that would be 29 for our Q1 minus 1.5 times 13. And I get 9.5. There was nobody below 9.5 in age in the data set. And so there were no lower outliers there. So flipping over to our next page, number 8 here says, use the two-way table below. Which major between political science and sociology has the higher probability of an applicant scoring above 700? So I'm looking specifically at political science, at sociology, applicant scoring above 700. So if I look, political science had 4,251 people scoring 700 to 800, and sociology had 599. So it's very tempting to say, well, there were more people in the political science, 700, 800, than there were in the sociology, so political science has the higher probability. But if you look at the totals, there were way more political science majors taking the GRE compared to the sociology. So of course they had more people scoring 700, 800. They had more people in general. They also had more people scoring below 700. So what we need to do is calculate some probabilities. So for my political science majors, we had 4,251 out of 19,960 score 700 to 800. So 4,251 divided by their total. And that gives me 0.213, or about 21.3%. And then for sociology, that probability is going to come from the 599 out of their total, which is 4404. 599 divided by my 4404, and that gives me 0.136, or 13.6%. So who has the higher probability? Political science ends up having the higher probability at 21.3%. Moving to number 9, which variable would have the higher standard deviation and why? A is the daily high temperatures of Tallahassee during the summer, and B, the daily high temperatures of Tallahassee throughout the year. What you're going to remember here is that standard deviation is a measure of spread. So we're saying which of these has the higher standard deviation, which has the higher spread. So if we think about daily high temperatures in the summer, it is hot all summer long. Most days it's in the 80s or 90s or even the lower 100s. That's the high. And if we think about throughout the year, well, that's the entire year, January to December. So, some days it is very cold. Some days it doesn't get out of the 30s or out of the 40s. And then you still have the summer temperatures where it's in the 80s, the 90s, 100s. So you've got a wider spread of temperatures throughout the year. So we would expect that variable B, the second one listed here, has the higher standard deviation. And that's because the temperatures are more spread out throughout the year. They are not as close together as they are in the summer. Moving to number 10, research group decides to study the relationship between coffee and REM sleep. There are 4 randomized groups. First group gets no coffee for a month. Second group gets 2 cups of coffee each day for a month. Third group, 4 cups of coffee each day for a month. The fourth group drinks 2 cups of decaf each day. REM sleep is measured each night. The study shows the third group has significantly less REM sleep each night. Is this an observation or an experiment? This is an experiment. We have 4 randomized groups, each doing different things. We've got a controlled experiment. We're not just asking people about their coffee consumption and their sleeping habits, but we are splitting them into groups, having them do different things. It's experimental. What conclusion can be made from the study? So because an experiment, we can say there's a cause and effect relationship here, that drinking 4 cups of coffee each day causes a significant reduction in REM sleep. I would say from that third group, drinking 4 cups of coffee each day has a significant reduction in your REM sleep. That's the cause of that. And the purpose of that fourth group, the fourth group drinking 2 cups of decaf, that is your placebo group. So we'll stop this video here, and we will have one more video to close out our study guide.